Hello friends, and welcome to a lecture on operation research. Today we will be studying dynamic programming. This is Professor Arvind Prasad. In dynamic programming, we'll take up the most popular example which is used to demonstrate dynamic programming, that is the Stagecoach problem. Well, before we go into understanding the problem, let us take up a few fundamentals. The sum of n numbers is 1 plus 2 plus 3 plus n. Well, it can be written as a function also for simplicity. That is, sum n is equal to 1 plus 2 plus 3 plus so on and so forth till n. Now, if we put n in this function, that is the sum n function that we have written on the left hand side, if we put n in this, we get the sum of n numbers. Let us say if we put in 3 here. So we are going to get 6. Quite interestingly, sum n can also be written as n plus sum n minus 1. Now, to understand this, let us say if we write, we want to calculate sum 3. So sum 3 is going to be 3 plus sum n minus 1, that is 2. Now, sum n minus 1, that is 2, is going to be 3. And 3 plus 3 again makes it 6. So sum n is a recursive function. Such functions are known as recursive functions. What are recursive functions? Recursive functions are functions that call on itself. So here we are with the Stagecoach problem, the classic Stagecoach problem. Now let's understand this problem. In the good old days in America, when the America was wild, it was a wild west, you had fortune seekers. Now what did these fortune seekers exactly do? They went from one city to another, discovering new cities to find gold. Well, what they did? They went there, they start digging it, and if they found gold, fine, they've struck gold and they would become rich. Now, obviously it was wild and it was west and it was dangerous to travel from one city to another city. So the classical Stagecoach problem shows it all, where the fortune seeker wants to go from A to J. Going from A to J, he has to go through cities B, C, D, E, F, G, H, I. That is, from A, he could either go to B, either go to C, either go to D. And from there, that is from either B, C or D, he could either go to E, F, G. And from E, F, G, he could either go to city H, I. And from H and I, he would only have one option but to go to J. Now for all these routes, there is an insurance. That is, you could buy an insurance for travel. Routes which are very dangerous have a higher insurance cost, and routes which are not very dangerous have a lower insurance cost. Now for the fortune seeker, he has to plan his route in such a way so that he pays the minimum insurance to reach from A to J. Now, this is pretty complicated because, first of all, starting from A, he can either go to B, C, D, and then going from B, C, D, that is starting from either B, C or D, he can again go to E, F, G, and he has many choices, and in all those choices, insurance premiums are involved. So how do we find a route from A to J which has the minimum insurance premium? Now, this is an abridged version of the problem that we had in the previous slide. Well, abridged version means a shorter version of the same problem. But yes, the fundamentals remain the same and it's easier to explain because you have fewer cities in this. So, he has to go from A to J. If the fortune seeker has to go, first he has to go to either cities B or C. Then from B or C, he has to go to either H or I. And from H or I, he naturally has to go to J. Now cities A, B, C, H, I and J, they are known as states. I repeat, they are known as states. Well, he can be in any one of these cities, so it's a state at which he can be. Right? Mathematically, a state is a place where you are. That's all. Now, the stage one of his travel is, the first stage of the travel is he is at A. The stage 2 of his travel is that he is either in B or C. The stage 3 of his travel, he is either in H or I. And stage 4 of his travel is he is at J. So from stage 1, he has to go to stage 2. And from stage 2, he has to go to stage 3. And from stage 3, he has to go to stage 4. Interestingly, in stage 2 and stage 3, he has choices. He has choices of his state. But in stage 1 and in stage 4, he has no choice of his state. Right? So when he has to proceed from A to J, he has to make a stagecoach run. Well, the stage is stage number 1, which is A, to stage number 2, which is B or C. So he has to make a stagecoach run. So the lines show the stagecoach run. So let's get ahead now. Let x1, x2 and x3 be the stagecoach runs. Now what are they? Now if you want to go from stage 1 to stage 2, the stagecoach run is x1. If you want to go from stage 2 to stage 3, the stagecoach run is x2. And if you want to go from stage 3 to stage 4, the stagecoach run is x3. Now what are these stagecoach runs? Let's get back. These blue lines are nothing but the stagecoach runs. Well, in between two stages, there are many such lines, and you choose one variable to define the run in between two states. Let's get back now. So if he has to go from A to J, he has to take stagecoach run x1, stagecoach run x2, and then stagecoach run x3 to finally reach J. In a bigger problem, we can write xn is the nth stagecoach run. Further, we define a function fn which has inputs s, which is nothing but the state, and xn, which is nothing but the stagecoach run. And what is the function fn? It is nothing but the total overall cost for best overall policy for remaining stages. I'll just explain that. Fn gives you the total cost to go from any stage. Now n could be, in our problem, it could be 1, 2, 3 and 4. Right? So if you're, let us say, at stage 2. So the function fn, when calculated at stage 2, gives you the total cost for the best overall policy for the remaining stages. It gives you the cost from going from stage 2 to stage 4. Now, what does best overall policy mean here? The best overall policy means here is we have various routes. Now, obviously, we cannot take all the routes. So there's going to be one route. Now that's the best overall policy. Right? It's a policy. At each stage, you have to take a decision which route you want to take to go to the next stage. There are multiple routes. Right? So that is what it means. So there is a policy involved. There is a decision involved at any stage that how do we take the route, which route we take to go to the next stage. So that is a policy, right? That is what a policy means. A policy means a decision. Now this decision is based on various definitions that you would give, or various ideas or various logics that you would give. Okay, based on these criteria, you would take the route. Now, this is further explained in the left below. If this function is applied to the first stage, so this will be F1 and S will be A because we are at state A, and Xn will be X1 because we have to take the first stagecoach run to go from stage 1 to stage 2. Now let's take the stagecoach run X1 from A if you want to go, that is from stage 1 if you want to go to stage 2, you have to take stagecoach run X1. So from A, if you have to go to either B or C, you have to take stagecoach run X1. The value of function at that point is going to be, that is at A is going to be F1A X1. Now X1 has two choices. It can be either from A to B or A to C. Now the value of the stagecoach run, that is the value of the insurance premium at A to B or A to C, out of these two, that value of the stagecoach run which minimizes F1 is known as Xn star, is Xn star. So in this function, if we put Xn star, it minimizes the value of Fn. So if you put Xn star, it nothing but minimizes the value of Fn. Moving ahead, Fn S Xn is nothing but the sum of the immediate cost that you have or you will incur in traveling away from stage n to stage n plus 1 plus the minimum future cost, that is the minimum cost which is from stage n plus 1 onwards to the end. So this can be written as CSXN plus Fn plus 1 Xn. Now, well, as you can see here, this is a recursive function. What is a recursive function? It's already defined here. So this is nothing but a recursive function. So at each and every point you have a policy. The function is nothing but the policy and it's recursive. It keeps calling on itself. Now, okay, let's explain this further. Let us say you are at A. So from A, you can go to B. From A, you can go to C. You have two choices. So F1A X1 is going to be nothing but CA X1. That is, it can be either 2 or 4. That is, CA X1 is either 2 or 4. That is the immediate cost plus the future minimized cost. That is the minimum cost which is from stage 2 to stage J. This is nothing but F2 star. Let's repeat it once again. F1A X1 is going to be nothing but CA X1, which can be either 2 or 4, plus F2 star X1, that is the minimum cost you require in going from stage 2 to stage 4. Explaining things further, F1A X1 is equal to CA X1 plus F2 star X1. We have already explained this. So, explaining it in the previous slide and reiterating it here, you have two choices. You have F1A to B, where CAB is going to be the cost in going from A to B, plus F2 star B. That is, from B to J, what is going to be the minimum cost. Or it can be F1A to C, which is equal to nothing but CAC, that is the cost in going from A to C, plus F2 star C. That is, if from C you go to J, what is going to be the minimum cost. Now the minimum of these two functions is going to be F1 star A. So now we come to a conclusion that if we want to calculate F1 star, we should know the value of F2 star. To know the value of F2 star, we have to know the value of F3 star. Of course, F4 star is 0 here because we are not traveling beyond J. Now, how do we solve this problem? Because to solve this problem or to find the value of the function at any stage, we have to know the value of the function at the previous stage. This is a recursive function. Like sum n is equal to n plus sum n minus 1. Now, if sum n is equal to n plus sum n minus 1, to find sum n, we have n plus we have to know the value of sum n minus 1. So, to calculate f1 star, we have to calculate first, or we should be knowing f2 star and we should be knowing f3 star. Now, how do we solve this problem? We do a very interesting thing. We start from the node or the stage which is 1 before the end. At end we have j. So the stage before j is nothing but 3. So we start at n is equal to 3. Now f3 sx3 will be csx3 plus f4 star x3. So here we have two choices. f3 h to j is equal to chj plus f4 star j, which will be nothing but 3 because chj is 3 and f4 star j is 0. Or we have f3 ij, that is traveling from I to j, which is equal to cij, which is nothing but 4 plus f4 star j, which is 0. So you have the value of f3 as either 3 or 4. So f3 star, you have two values, that is the value in traveling from h to j and the minimum value in traveling from I to j. So this is going to be 3 or 4. We move further to stage 2. Now at stage 2, you can go from B to H or B to I, C to H, C to I. So the states from which you can start, that is S, is going to be B and C, and the states where you can end up is H and I. Okay. So if you go from state B to state H, the total cost is going to be 7 plus 3, because from B you will go to H, the cost is going to be 7 plus F3 star H is going to be 3. If you go from B to I, it's going to be C is going to be 4 plus going from I to J, F3 star I is going to be 4. So it's 4 plus 4, 8. If you go from C to H, it's going to be 1 plus 3. And similarly, if you go from C to I, it's going to be 2 plus 4. So there we have it. Now F2 star, that is the minimum value of going from this stage to J from either B or C, from either states B or C, is going to be 8 or 4. That is, if you want to go from B to J, the minimum value would of course be 4 plus 4. So that's 8, right? Out of these two values, that is from these choices that you have from B to H and B to I, you select the minimum value and you put it here. So the minimum from B, that is stage 2, to the end is going to be nothing but 8. That is, if you want to go from B to the end, it's going to, the minimum cost is going to be 8. And if you want to go from C to the end, that is to J, it's going to be 4. So you have two choices now from B and C. At stage 2, you have two choices to go to J, right? It's going to be either B to I to J, or it can be either C to H to J. Fine. So we have now optimized here. We have now two optimized routes starting from B and one starting from C. Now Does this not get very interesting? From all the choices that we had here, now we have finally made a choice that we can go. Yes, if we land up at state B, how do we go to state J? We go B, B to I, and I to J. If we land up at state C, from C, it's going to be H, and then it's going to be J. So, out of all these choices, we have boiled down to the most optimized value of the choices. Now, finally, the problem just remains that what is the optimized value in going from A to J? Now, we already have the optimized function value in going from stage 2 to stage end, that is stage 4, starting with the states in the stage B or C. So, we further calculate from A, we can either go to B. So, this is going to be 2 plus the value from B is going to be 8. B to the end, it's going to be 8. So, the total value is 10 here. And if you go from A to C, the value is going to be 4 plus the value in going from, or the value of the function in going from C to the end is going to be 4. So that's 8. Right? So if we need to go now between these two choices, the minimum is 8. So the best route is going from A to C. From C, you are going to go to, so you have now A to C, and from C, you are going to take a choice of H, that is A to C, C to H, and H to J. So that's it. So you have A to C, C to H, and H to J. So that is the way, by applying policy at each and every stage, starting with the penultimate stage, you come to the first stage and you find out what is going to be the optimized cost in going from A to J. Now, can you apply this to this problem? It's not very difficult. Try it out. And do write the answer in the comment. I would be only too eager to know your answers, and we can strike into a discussion. So that's the end of my lecture, guys. If you like this lecture, do subscribe my channel. More such interesting lectures are in the pipeline. And if you want a lecture on any topic, or if you have any problem in operation research, do write to me in the comments and I would make a lecture. I will make a lecture for them and you can, of course, learn from it. And of course, if you like this lecture and if you like my entire channel on operation research, do forward the link to your friends who would be interested in watching it. Goodbye, friends. This is the end of the lecture. Have a great day. Have a great time.